So for the first part, for the Google Earth section, since running Google Earth Engine maps requires you to get online, and it's better if you have a little bit faster connection, I'm not actually going to run the Earth Engine script here. Also, if you have 20 people trying to hit the server from the same place on Google Earth, bad things happen. So I'm just going to go through and describe some of the kind of useful parts of Earth Engine real quick, and then I'll go into the code. I don't actually have the raw code up here. What I've done is I've rewritten it as something called pseudocode. So are any of you kind of comfortable with coding or programming, and maybe you've heard of pseudocode? Okay. It's just usually when you write pseudocode, you're going through and you're getting ready to write a program, a chunk of code, a script, and you're trying to think through all the parts you're going to need and how they fit together, and make sure that you do things in an order that is sensible, for example. But it's written in English instead of in a formal coding syntax, so it's a lot more readable. So I rewrote our Earth Engine code as pseudocode, so you can see, like, step 1, this is what we're doing. Step 2, this is what we're doing. And it's just a lot more readable, I think. And also, I think it might be useful if you guys ever do this, if you guys want to try writing your own pseudocode before you do it, it really does help you kind of figure out what you need, how exactly you need to organize, your code as a whole. And I think it's just worth seeing. But before we get going on the pseudocode, just a bit about Earth Engine itself. It is cloud-based, so basically you're busy writing away your code in the user interface, but when it goes to actually do the work, your code is basically accessing, or you're using your code to access various servers from who knows where to do the actual grunt work of processing your imagery and creating your map. One of the perks of using Earth Engine is that it's got access to lots and lots and lots of different sources of imagery, all in one place. And you don't have to download onto your computer. You can just access it through the cloud. So there's no upload, download of big data sets. I think Guar has pointed out that the processing for the Sentinel imagery that's available on Earth Engine is not as good as if someone like Guar went through and made it better. So that's something to keep in mind. But
they don't give you the tools to carry out the processing either. They just at the moment they just give you access to the eSert project.
Okay.
I think, don't they?
I think that it's the. I don't think that it is the. Yeah, I don't think that it is.
Disposal,
So just be cautious with, for example, the Sentinel. Just something to throw out there. But there is easy access to a lot of data products, not just Sentinel out there. You can use either JavaScript or Python, but most people use JavaScript to actually create the scripts. But if you are comfortable or at some point begin learning Python, you can kind of manage a lot of Python through Earth Engine. What I've done so far, I've been using JavaScript pretty much, even though I know Python better than JavaScript, which is, I can't really say I know either of them, but I know one better than the other, and it's not JavaScript. But even I can manage it, so that means that you guys would be okay. If you want to go ahead, if you guys ever want to go ahead and check out Earth Engine, basically all you have to do is log in, just do a Google search for Google Earth Engine, and you'll be led to their main webpage, and you can just say, hey, I want to create an account, and then it's really easy. And you actually do not get a default login for Earth Engine just having a Google account, but if you enter in if I recall correctly, you might actually, It might auto-fill out a lot of your stuff when you do it, if I recall correctly, but yeah. It's either way, it's not, it takes 2 minutes to sign up for, and then just wait for the confirmation email.
Brian, just so you touched on the JavaScript and Python. Just so within the project, we were trying to, because Bran's a lot of coding for the Google Earth Engine stuff, we were trying to come up with some easier forms that people can, so the non-technical specialists could change what input data layers were going to be going in rather than you deleting bits of code and adding bits of code.
Yeah. The simplest way, I think, would be to see if we could use Google Forms, to be honest. But
so that was a plan. That's the plan with the project still. We're still looking at that.
Just make it a little bit easier.
Yeah.
That way, we don't have to pass off the code and have someone search for the parts they may want to change if they want to run it. So the maps that we did create, as the maps that you saw first day in the beginning slides that had Falklands and South Georgia, lots of blue, lots of green. They were pixel based, and they were classified using random forest, like we discussed yesterday. The ground truthing that we brought in, we tried it 2 ways. We tried just dropping it in manually in Earth Engine. And after a certain point, that became inefficient to manage the points graphically. So we ended up using a fusion table, which is basically a fancy spreadsheet that you can bring into Earth Engine. Unfortunately, it turns out they're deprecating. They're getting rid of fusion tables in December. I'm not sure what product they're going to replace the fusion tables with. I'm assuming they're going to have a new option. There has to be some equivalent that they're going to use. I mean, there are a lot of people like fusion tables. So when that happens, I'll figure out how to, famous last word, I'll figure it out later. But I'll see if I can work something out to replace the fusion tables. But basically, we're now just loading CSVs, creating these fusion tables, and then we're storing these fusion tables on our Google Drive and having our script access our drive to take a look at the ground truthing data.
So the fact we're using Google Drive doesn't mean then you will need a Google account?
Yes, but that's just a matter of setting up if you set up a Gmail account, if you have a Gmail, or if you set up a Gmail, which is free, you'll get a drive, and you'll get plenty of space to put that sort of thing on.
30 gigabytes.
30. Oh, they've raised the limit since I checked last.
Are you going to mention the limitations of Google Earth Engine? Like, you can't use it for commercial properties, and it's a bit dodgy for using it for operational projects as well, because Google is basically giving people access to this for free, mostly to do research off their own back. There's no real reason why they should be doing this, as opposed to just somebody in Google has an interest to provide this as a service. So if they decide one day that they want to stop doing that, then this kind of goes away.
There is no guarantee. There is no guarantee this will always be there, but it's very popular.
And I think they are putting in a process where you can pay to use Google Earth Engine.
You can pay. You can pay to have more access to data and things like that. But you still.
To make money, I think that's coming.
I hadn't heard about that. I do know that you have to pay to get more access sometimes to like data storage, like a fairly nominal fee. But
so on their website, the one that Bran pointed to, you'll go down, and if you want to use it for commercial purposes, you have to get in touch with them. And whatever happens after that, I don't know. So
yeah.
Got that far.
Google gets a lot of good press from Earth Engine, and so I don't see them taking it away anytime really soon. Also, the people that I have worked with from Earth Engine, at least, and I don't know everybody, but the people I have worked with have been really flexible. They've been nice. If you just tell them what you're doing, they're like, "Oh, okay, cool." They're low key, and they're also really nice about answering questions. So just to keep that in mind. Yes. So just to give you an idea what the fusion tables look like, you can. I can give you guys these slides if you want, but if you want to create a fusion table, you just go into Drive, new file, fusion table, and you just load it in. One thing to keep in mind with this script is that it is set to operate within a user-defined area. So right now I have this red blob over the Falklands and down to Beauchene. If you wanted to just use the script to go over the entire island and a little bit out to sea, then you would just leave it like that. But if you were just testing stuff, or you were only interested in a small subsection, you could redraw this shape so it was much smaller, and your script will run a lot faster. You use less less bandwidth up doing that. So if you don't need the whole island, I would definitely draw a smaller polygon. It'll help you guys. Oh, Neil, were we planning on giving a link out to, even if it's not the final project, but like an example script for people? Okay. Okay, so I'll put my email up, and if you guys are interested, I can put kind of a streamlined version of the script up and give you guys a link, and you can play around with this yourself. So, and don't worry, it's a completely separate copy. If something weird happens, you're not messing with the original. You can do whatever you want; it'll be okay. So, all right. So I'm going to start in on pseudocode now to actually show the actual main components of the script that we've created. So just some housekeeping. 3 asterisks in my code is basically shorthand for saying that there's something here that the user has to look at and decide if, either you leave alone what it is by default in the script, or if you want to change it. 3% signs means that users might want to change it, but you don't have to. It'll run fine without changing it. But you might just want to keep that in mind if you want to go into more depth with the script. And as I already mentioned, our project, we used Sentinel-1 and 2 imagery that Guar had already kind of gone through. So we are accessing it as an asset, which basically means that we're accessing a copy of that we've uploaded to Google. So we're not going the usual route that you go in Earth Engine for these data, where you go say, hey, Google, I want imagery from this data set on this date at this location, or in this date range. We're going directly to those files that we saved. So it's a little different for these guys. So just throw that out there.
So that's the benefit of the Earth Engine. You can pull down that data.
You can do that. There is a limit to the amount, the size of the, just the data that you have available. There is a practical limit on it, so you can't just put all the data in the world up there. But you do have enough to put a couple projects worth of data on there. So, okay, so when you get going, I'm sorry. Okay, so when you get going, the first thing that you do right out of the box is import your data. Usually we import it as something called an image collection, which is basically just an assortment of files that you're going to use. And you specify these files, these images, with details like the time and date, the location that you want the imagery from, and whether you want whether you want to sort by cloud cover. If you are concerned about cloud coverage in your area, which most of us are, and cloud is actually a pretty big factor for remote sensing pretty much anywhere. For us, we use Sentinel-1 and 2 from Guar. We also use some Landsat sources, and later on there are a few other sources we'll pull in, but as far as imagery goes, this is what we were really working with. Then you set your working area. So you set where the center of your map is going to be, and then you say the working scale that you want it to be at. So whether you're zoomed in or zoomed out.
Is that where you would clip it if you were?
You could do that even before you started, because you can do that graphically with that little polygon.
Oh, okay.
Yeah. But you can do that at any point, but it's good to do that before you get going, so you don't hit start and you're like, oh, it's the entire island? It's going to take until after lunch. So
So all that does is, you've got that user interface. It means that it sets your, the area that you've drawn right in the middle of it. So you're not seeing out a really zoomed out version or a really zoomed in version. That's what that does.
And actually, before I forget, just a tip: if you guys are using Earth Engine, when it is actually doing calculations, when it's running a script, don't move the screen around. That will use up memory. Like, don't try and pan around so you can see different parts of the image. Like, is it working over in the south? Is it done? Just leave it be. It will take much longer to run if you start messing with it. So just like walk away. I have to walk away, or else I'll just start clicking things.
It's quick though.
So
Surprisingly
it's pretty quick. I mean, that's the nice thing about all the servers doing all this work for you. But you do need to give it some time.
And you were using it down here last summer, so it's
Yeah.
So it's not like Bran saying it's quick when she's in Oregon. It's fairly quick when she's working down in the Falklands.
It's still reasonably quick here. I mean, there is part of it when you actually load the data, it does take longer here, but the actual processing does not, because that's server.
But to be fair, the main base of Google Earth Engine is really up the road from Bran in Oregon. So
Yeah. So, yeah.
Shorter distance in every way.
Yes, we are neighbors with Reading. So, next step, I imported the Srtm data, which we kind of referred to in passing a couple times. It's basically pretty much, not quite worldwide, but throughout much of the world, digital elevation model, DEM kind of model of like the surface of the land anyway. And it's not perfect, but if in some areas it's what you've got. And we'll use this later to take a look at slopes and aspects and just how the terrain kind of works. But right now I'm just pulling it into the script and making sure that the script can access it later on. We don't really need so much for GWAR stuff, but there's what's called a topographic correction, and we use a fairly common approach called a cosine correction. But the whole purpose behind a topographic correction is to take your imagery and to take a look at your topography. So the information you got from your DEM and what the surface of the area of the land is like, flat, hilly, in your working area, and to try and kind of backwards engineer the appropriate lighting conditions so that you kind of reduce the shadows and you reduce the impact of the terrain on. I'm sorry, you reduce the impact of light and shadow kind of interacting with the terrain. So if you have a bunch of shadows falling on a hillside, it won't get rid of it, but it will help address some of that dark versus light that's in your imagery, because that can cause some trouble later on. And in this one, this is pretty much set to go. You don't have to change anything in the script. Just kind of leave it be. We import the ground truth thing from the Fusion table, so that's just a matter of like, hey, here's where my Fusion table is stored on my drive, and this is what I called it. Go grab it. And then once you have that, the ground truth accessible to the script, then you make a brand new data set I call it training points. And I'm basically just merging the data from, pulling the data from the Fusion table into this new format that's more accessible to the script, basically. And next, now that we have all our points, at least we know where they are and what the land cover type was that we decided that those ground truthing points were. Now what I'm going to do is, sorry, did someone raise their hand or? Okay, sorry, thought I saw movement. Now what I'm going to do is I'm going to have the script examine the imagery, all the different image sources that we're pulling into the script, and I'm going to go to each one of the ground truthing sites. I'm going to examine the imagery and what all the bands are within imagery are saying at each of these locations, and I'm going to record what's going on at each of those sites. I'm just going to make a big table. It's going to be like, you know, for ground truthing point 1, for Sentinel band 1, it looks like, you know, I've got this number, and then band 2, this number, and it's going to make a big long list. I'm doing that for all the ground truthing, and I'm putting it in a table. And then the next step, after we've pulled out the information about the imagery at all the ground truthing sites, I'm going to do the same sort of process of extracting information about, you know, an input layer, but instead of being an imagery, I'm pulling information about the aspect, elevation, and so on and so forth, and pulling that into the same training points data set that we've been adding information to. So now that we've kind of pulled in the basics into this training points data set that we're going to be working with pretty much from here on out, I calculate the Ndvi, same way that you guys did. And then I calculate a few other matrices that are, indices that are like Ndvi. They're meant to kind of look at different characteristics in your data and try and pull out, you know, different features. So I do something called Geary C, which is basically trying to see, like, kind of, I guess you could say if you're trying to see if there are kind of shapes that form in the imagery and if they kind of link together. This helps flag those areas. We do EVI, which is EVI was developed to fill a similar kind of niche that Ndvi does, but it's less sensitive to some of the conditions that can mess up an Ndvi metric. We do Ndwi, which basically tries to assess whether a leaf is dried out or healthy and green and has a lot of moisture in it. So it's like water stress, for example. It's commonly used for that, but it also helps kind of pick out plants that are a little less fleshy, I guess you could say. Okay, so
what does the you said EVI fill some of the niches left from?
Mm-hmm. Like for Ndvi, one of its weaknesses is that when there's a lot of water on the ground, it will cause a lot of readouts that are incorrect, and it'll throw things off, for example. And it's just an attempt to try and get around some of those weaknesses. So, I mean, it
also saturates at very high, so anything above 0.8 as an Ndvi.
I forgot about that. Yeah.
Because it has a saturation point, and the other vegetation indices are much better at dealing with the saturation level. So Ndvi is probably the first of those kinds of indices.
I think it was the first one they developed, right? Yeah.
The metrics have been developed that are slightly better to encounter the limitations of that. People still use Ndvi.
It's a classic, and it's something that, well, like we did, it's just like NIR plus or minus red and over, and then plus on the bottom, and it's easy.
Only band statistics, so a lot of the other indices pull out numbers from.
You also need, and you also need,
which is hard to understand.
And also a lot of the other indices, I mean, you can take a look at them, but they require factors that might, they require variables that are site dependent. So you've got to figure out, like, okay, what number should I put in this equation? Am I really putting in the right information here? So it's just more complicated, but it might be worth it if you have a specific purpose.
Can you use Ndwi to map water features?
Water features?
Water features, yeah.
I guess in a weird way, it would show up kind of a negative,
So
but
Ndwi,
I mean, it would.
because there's two different versions of Ndwi. So if you're using the Ndwi that pulls in shorter infrared band from data, which not every sensor has shorter infrared band data, then they're specifically related to the water stress content in the, remember the spectral signature I showed on the first day? Well, they're related to the water dips in the signature. So it's a vegetation index. But then you have an NDWI that's between the green band and the blue band, and then that would be better for picking up water features because it's related to the water presence as opposed to being a specific vegetation index. There's also a water band index, and there's hundreds of these indices around. So there are metrics that you can produce that highlight specific features in the landscape that then make it easier to extract things like water features.
So if we can, I'm thinking, if we have indices that can extract information from the images for us, then can we not use those indices instead?
Yes, but that's common. That's what we're doing.
You can just create a map of the results of the indices. Actually, I've used the EVI a lot of times to just look at. I've just like exported I've created EVI. Well, I did it in ARC, but I was using it to look at like what was going on with some of the ground truthing. Actually, I was like, is this really what it looks like? And
but the power of the random forest classifier is you can feed it as much information as you want, and it will pick out the most suitable layers. Let's call them layers. So you've got all of your bounds from your images, you've got all the indices, you've got your slope, your DM, whatever in your list, and then the random forest classifier will actually cut down all of those indices based on what you're trying to classify based on your training data from the field. So it'll decide which one of those layers are most important to get a better output, and then it will produce your output. So you can feed it as many of those input layers as you like, but that's where you can control it as well. So if you think that a specific index or layer should work very well, then you can force it to use that to create your output. So there's lots of clever ways you can use the classifier to give it the context that it might not need, might not have just from the imagery alone.
And like Laura said, I mean, you can keep throwing more and more and more at this type of classifier, but I would point out that I found when running Earth Engine especially over an island-wide scale, when I got a lot of classes, when I had lots and lots and lots of classes I was trying to map, it did hit a processing ceiling at around 17 classes on an island-wide level. So just to bear in mind that at some point it will just be working too hard. You know, the actual processing that it's going to have to do is just going to hit a practical limit. But you do have to work a while to get to that limit. But just be aware that it exists at some point. You might be better off. I think if it's a smaller area, you might be able to still get away with a lot more. You know.
So that's actually a limitation of Google Earth Engine.
It is. So if you're doing QGIS or something, you could probably get away with more in QGIS if you did an equivalent in there. All right, so next thing that we do, and this is what we were talking about yesterday, where we split off a subset of our ground truthing data and hold it to the side and use it later on to test how well our map turned out. Well, right now, this is exactly what we're doing. We're pulling a subset of our ground truthing data aside, saving it as a new file, and we're saving the rest of the points in another file. And from this point out, we'll be running the classifier with that bigger set, the training data set, and we'll bring the validation data set, the smaller one, in later on after we've done the map, after we've created the map. Which is what this is all about. This is just the housekeeping for setting up, like how you set up a randomly assign whether a record goes into the training or validation. And the next major component that you work on is setting the parameters for the classifier. Now that you've got the validation data and the training data separate, now you get to actually set up your parameters for the classifier. So at this point, you're almost done. So, I mean, seriously, you go through like 200 lines of code and you finally get down to classifier and it's one line. But yeah, that actually does the work. But as far as the parameters for the classifier itself, you can set the number of trees. So a small forest will have like 100 trees. Big forest will have 1,000 or more. And again, this is a practical limitation for Earth Engine. If you're working in a big area and you have lots and lots of trees, it might either go really, really slow or it might ultimately time out. But if you are working either in a smaller area or you reduce the number of trees a little bit, then it should be fine. But just remember, if it's timing out on you, just take a look at the number of trees. Accuracy, map accuracy usually goes up with increasing number of trees, so you want to have as many as you can manage and still have the script run okay. I would recommend. We run at 1,000 usually. We've done some at 100, but we run at 1,000 usually, just as a starting point.
I mean, does that sort of depend on how big an area you're looking at?
Yes, you can, like if you were going to just do like, if you're going to just do like an area right around Stanley to Cape Pembroke or something like that, you could double, triple the number of trees easily. But if you're doing the entire island, you might want to go to 1,000. So, so yeah, number of trees. There's some other odds and ends that are in there with the parameter. That's the biggest player. Just remember, take a look at the number of trees. And finally, here's that one line. You actually apply the classifier to the training data set. So that training data set, that list of ground truthing points that you have all the information stored to for all the bands for the imagery, all the different indices you created. It's just a big table. Now it's just taking the classifier and making its best guess based off of that table what the rest of the map is really like. So it's going to go through each pixel in the map like this, and it's going to look at its record from the ground truthing or from the training data set, and say, I've got this new pixel, and it's got this value in band 1, this value in band 2, and this value in band 3. Which one of these classes I have a record of is this pixel most like? And that's how it decides what to call that pixel. And it just goes through the entire map and does that work. So the rest is just basically, now that you have the map, now you're checking the validity of the map or map accuracy. And this is not a perfect way of checking it. You're only spot checking. Really, the first thing you're going to do realistically when you open the map is like look at it and like look at areas that you know and like, does this make sense? But this is just a slightly more quantitative way that it's kind of easier to pass off to other people who might not know your area, your map area as well as you do, for example. And so, there's other ways to do it, but what we did was the confusion matrix. So it was that table that we showed you with the on the first day with the rabbits and the cats and all that for the different classifications. So it's just going to be a big list, and it's going to have all your classes going this way, and then another entry for all your classes going this way, and this is going to be your actual and then your predicted, and it's just going to hopefully all your points that according to your validation data set were actually water are going to be predicted as water as well. But there's going to be cases where what was classified as water is actually going to be, I don't know, kelp or something, or beach or, So you just go through and you take a look. At this point, it's good to just see if there are classes that seem to get mixed up with one another a lot. That might mean that you need to go out and do some more work with your ground truthing or just kind of figure out what's going on. But it's a good point to just kind of take a step back and see if everything still makes sense. But beyond that, at this point, it's just a matter of, if you wanted to display it in Earth Engine, in the script there is, if you want to display the output map in Earth Engine, there's some settings that we have in the script that allow you to change the colors for each classification, take a look at it in Earth Engine. There's also, we have an export component for the map itself and also for these tables. And that should be yeah, that's it for the broad scale. So I guess real quick before food, is there anything that you'd like clarification on or anything like that?
So if you're using the Google Earth engine, you can't export your output as vector data.
I actually don't know for sure if maybe you can or can't. I've always just exported as a geotiff and then brought it in and done my work from there, like creating nicer maps or doing more work with the image itself in ARC or QGIS. That's a good question, actually. I've never looked into that. Have you ever? You or Alejandra ever come across?
With the difficulty, they don't make it easy for you to export output from Google Earth Engine.
No, they don't. They don't.
And because their challenge would be, why would you want to? I guess because you're just doing this for research, right? And if you're just pulling out a JPEG of the output, then why do you need to export the data itself? That would be their challenge, I guess.
It'd be nice if you could, because the files would be much, much, much smaller and a lot faster.
You can export it as a geotiff and then convert it in.
Yeah, that's what we do is the geotiff export, and then we work with it from there. But it'd be worth looking up if you could. So it'd be really nice if you could, because it would be a lot faster. But anything else? If you guys are interested in getting into Google Earth, there are tons of tutorials out there. There's when you sign up, if you do sign up for an account, there's a kind of a community, I guess you could call it, of users, developers, and I've had good luck just going and finding tutorials. The people that I've been in contact with from Earth Engine have been really very accommodating, and actually Alejandra has probably worked more with them on that side of things than I have.
I really like
So,
working with them.
Uh-huh.
They're super open.
Yeah.
Very keen to answer any questions you have.
Yeah. So, yeah, don't be worried about talking to them though. They don't bite, I don't think. So.
They're also a very small team, so there's only like a handful of them.
Yeah, the same names
They're
keep
there
cycling
because
around.
They enjoy their job, not because. Which is why they're very nice people to talk to.
Would you say, are you saying those that hate their jobs, they won't talk to you?
Well, when you think of Google as a conglomerate, it's not what you think of, is it? So Noel Gorelick is the person that's behind Google Earth Engine, and he's the one that designed Google Mars. And he's very good, and he's very friendly, and basically Google have given him free reign, essentially, and Google Earth Engine is his baby. And it's because he enjoys helping people and enabling people to do it.
Yeah, and if you email him, he will email you back.
And also people want his profile, right? As long as they get the profile. So they will demand that you put them as authors on papers and stuff like that, which, why not if they're helping you out with achieving your outcomes? But that's the only thing they actually demand.
I think it's a really good summary, Bran, of the Earth Engine stuff. I've taken a step back from my perspective, and I think important for the project, but also going forward after the project finishes, and some help people feel more comfortable when you don't have the likes of Bran there to help you. And that's going to be, as I said before, sorting out those forms or some way to easily change the settings that you talked about in the pseudocode, so that you don't need to pour through pages and pages of script. Because I've been through it, and I say it's fairly intimidating to go through all that script.
You're saying my code isn't beautiful?
It's amazing. But if not used to doing coding, then it's not. You can't just jump in there and do it.
It looks like a mess when you first see it. It's like, what is this?
Coding, because Google Earth Engine won't
That's true.
You create
That's
your own functions. You have
she
to
is
use
right.
Functions that already exist in Google Earth Engine.
Yeah, Guar is right. We're
You have
accessing other
to
stuff.
get them to do it for you. So that's another, positive if you're not familiar with, I would call it scripting, not coding. But if you are competent at coding, it's a limitation. So it depends.
But if you're to that level, you're probably not using Earth Engine.
Yeah.
So this is for like us regular people.
Yeah.
So, yeah.
Completely agree.
No, it's true. It's like I only figured out most of the stuff from looking at tutorials and like, how do I do this? You know. So.
But yeah, my point is going forward. If we want this tool to be used going ahead, then it has to be as simple as possible. And I guess the more we can make it simpler, the more likely it's going to be used in the future. So I guess we're taking the message from that.
I can see why you were excited when you got the maps at the end.
Yes.
It's like having now seen the whole process.
Yeah. 200, 300 lines later. It's much more like 350 by that point. It's just like.
Yeah.
But it's
But
super
also
quick
you
to
mentioned-
rerun.
Sorry.
Yes.
Once you set it
Yes.
all up, it's super quick to rerun.
Yeah, it is actually.
So if there's any issues that come up, you know, or any other layers you want to put in, or any other ground truthing data that's appeared,
The skeleton is already
really
there.
quick. You don't have to start from scratch each time, which
That's
is the
what-
benefit of code.
Yeah, and that's the benefit. I guess
And-
that's an output for the product.
Yeah.
So the idea being that you just need to add new ground truthing data, and if you want to look at new imagery, you can add that, and then you just hit the button again, and it will repeat the process. So
Yeah.
And
you don't have to do all the work the brand's done through the project. It literally is a case of.
yeah, I mean, if you guys wanted to take what we'll send around and just take it to your own area and just adapt, you know, kind of the scale and you know, extents to be appropriate for like a work site you're doing, and just bring in your own ground truthing, and then it's pretty much already there. So. I would also point out that there's tons and tons of additional kind of bells and whistles that are available in Earth Engine, like lots of, like if you want to run stats on all the different classifications in your map area and things like that. It's available, it's out there for you guys to explore, and it can be really useful.